Okay, so I go to 97 longitude, 25 north, just above Capricorn. Okay, that's 90 degrees. You see that line? That's 90 degrees from the longitude. Okay, there's no arguing that. Now I'll show you where that goes. It only lets you draw great circles in Google Earth. So that's a straight line. So if you look 90 degrees there, this is what the direction you will be looking, period. So look, it doesn't stay lined up with Capricorn, does it? So our line of sight is not following Capricorn. If it were, then we could be looking parallel to the other latitudes, but our straight line of sight doesn't follow the latitudes. So there's no getting past this argument here, okay, because this is a straight line of sight, great circle, and that's due east. That is looking due east from that point, okay? So you can't say the ground's curving left or right, okay? Only straight ahead, which does not change the left to right angle. So this is why I use this example, so you can't try and twist shit, curve it left or right. This is a straight, great circle, straight line of sight. Though the ground will be dropping down, it will still be a straight line of sight off into space at that angle. So I go down south along the same longitude to 25 south. And look, that's due east, 90 degrees. Okay, I'll show you it's 90 degrees, and it's a great circle. And it's Capricorn, it's deviating, not our great circle line of sight. That's our straight line of sight from that orientation. So our straight lines of sight along the longitude are converging at about 6,000 miles. Period. Deal with it. So this is our line of sight just above the Tropic of Cancer, looking due east. So say you're on the ground and you're looking due east 90 degrees. We don't see along the Tropic of Cancer. This is what we see. Okay, the sun would be coming up right there. Okay, if we're looking due east and we see the sunrise, just like I pulled my string lines on the beach, and that big line would be like a giant string line. Okay, that's where the sun we would have to see it if we're seeing it due east from that position. Okay, and that's claimed what we see, but it didn't think it through. Because if I am by Capricorn at 25 south along the same longitude, I will see the same thing. I'll be looking in the same spot. Okay, angling toward the equator, angling up toward the equator in that example. And that's all fine and dandy, but that's not parallel. We're not seeing parallel. We'd have to see along the latitude lines to see parallel, and that's just not possible. So it doesn't matter if we come up off the ground as we go toward the sun. It's still there in that spot, and it converges. Our line of sight converges on a globe looking toward the sun due east. So we're on the same longitude, but we cross the equator and go to 25 south. Pull a giant string line, waiting for the sun to come up, and bam, it comes up due east. But the problem is due easts converge on a globe. Okay, the latitudes don't converge. The parallel latitudes would work perfect, but I've done showed it's impossible to look along the latitudes. So these are straight lines of sight. They converge locally. So it doesn't matter if it's looking off into space. Even if we get higher and higher off the ground heading toward the sun, we're still converging locally, left to right. This destroys a 93 million mile sun, period.